Hello everybody, you are welcome in Math Department in Horizon Language Schools. Our lesson today is about equality of two algebraic fractions. Before we study this lesson, we have to take an idea of or a definition of reducing fractions. What is the meaning of reducing fractions? This means that we have to put the fraction in its simplest form. For example, 28 over 49. This is a fraction. Reducing this fraction is putting it in simplest form. Dividing by 7 equal 4, dividing by 7 equal 7. So 4 over 7 is simplest form of 28 over 49. The same will be done in reducing fractions. For example, reduce the fraction nx equal x squared minus 4 divided x squared plus 3x plus 2. At first, we factorize each of numerator and denominator. Then, nx equal x minus 2 times x plus 2 over x plus 2 plus 1. After factorizing the numerator and denominator, we determine the domain of this function. The domain we denote by g is r difference the zeros of the denominator. When the denominator equals 0, x equal what? X equal negative 2 and negative 1. After determining the domain of this fraction, we can remove the common factors. Remove x plus 2 with x plus 2, then nx will become x minus 2 over x plus 1. This form is simplest form than the initial form or the primary form. That is what we mean by reducing fraction. Reducing fraction is put the fraction in its simplest form after determining the domain. This function is equal to this function. In what? In this domain. Okay? Okay. Now we start our lesson, which is equality of two algebraic functions. Definition. Two algebraic fractions n1 of x and n2 of x are said to be equal if the two conditions are satisfied. In the same time. In the same time. The first condition is N1 and N2 has the same domain. Number 2, they have the same rule after reducing. Okay, so if we have two algebraic fraction function and we have to decide which they are equal or not, we have to ensure that these two conditions are exist. N1 and N2 have the same domain and they have the same rule after reducing. Example. Let N1 of x equal x squared minus x over x over 3 minus 2x squared. N2 of x equals x over 2 minus 3x plus 2 over x over 3 minus 4x squared plus 4x. Prove that N1 of x equal N2 of x. Solution. At first, we have to factorize each of these fractions. Then determine the domain of them, of each of them. Then remove the common factors by reducing each of them. Then we say if these conditions are satisfied or not. So we begin with N1 of x, N1x equal, the numerator is, there is x common factor, the remainder is x minus 1, the numerator is x squared common factor, x minus 2, the domain G1 equal R, difference the zeros of the denominator, which is 0 and 2, which is R difference 0 and 2. Then N1 after reducing becomes x minus 1 and x over x minus 2. 1. The same steps were taken on the second fraction. The numerator can be we factorize the numerator after we factorize the numerator x minus 2 minus 1 In the denominator, sorry, we take at first x common factor, then x squared minus 4x plus 4 equal x minus 1 times x minus 2 over x minus 2 over 2. This expression is perfect square, so it can be factorized as x minus 2 power 2. The domain D2 equal R difference, the zeros of denominator, 0 and 2. So after removing the common factors, x minus 2 removed by 1 of x minus 2, so the remainder is n of x equal x minus 1 over x times x minus 2. From 1 and 2, we notice that n1 and n2 has the main domain, the same domain, are difference 0 and 2, and they have the same rule. After reducing from 1 and 2, we can conclude that n1 of x equal n2 of x. From 1 and 2, we use that n1 equal n2. Another example, example 2. Example 2. n1 equal n1 of x equals x squared minus 5x over x squared minus 7x plus 10. n2 of x equals 3x minus 15 over 3x squared minus 21x plus 30. Is n1 equal n2? Why? To ensure that whether n1 equal n2 or not, we have to find the domain of each of them and reducing each of them to its simplest form, and in this case we can decide the answer. Solution. The same steps will be taken. n1 of x equal x common factor x minus 5. The denominator x squared equal x times x, 10 equal negative 2 times negative 5. The result is positive 10 and the sum of them is negative 7.
the domain G1 equal. Cancel x minus 5 with x minus 5. The remainder is x over x minus 2. That is about n1. We take n2 also. n2 of x equal 3x minus 15. What is the common factor between them? It is 3. So we take 3 as a common factor. The remainder is x minus 5 over the denominator has common factor which is 3 also. 3. And the remainder is x squared minus 7x plus 10 equal 3x minus 5 over 3x minus 2 times x minus 5 as the previous expression. The domain D2 is R difference 2 and 5. Sorry, the domain here is R difference 2 and 5. Sorry. And then n1 of x will be cancel this by this. Remember, is x over x minus 2. Okay. Okay? Then n2 of x, after cancel the common factor, 3 and 3, remainder is 1 over x minus 2. This is d2 and this is will be 1. From 1 and 2 we noted that the two fractions have the same domain but they have not the same rule. We notice that d1 equal d2 but n1 not equal n2. So the two fractions are not equal. n1 of x equal x squared plus x minus 12 over x squared plus 5x plus 4. And n2 equal x squared minus 2x minus 3 over x squared plus 2x plus 1. Prove that n1 of x equal n2 of x in the common domain and find this domain. The first step, as we know, is reducing each fraction. Since n1 of x equal, directly I will factorize each of numerator and denominator. X times x, negative 12 equal negative times positive 4 and 3. Their times equal negative 12 and the sum is positive 1. The denominator will be factorized as x times x. Positive 4 equal positive times positive, and the middle term is positive 4 times 1. The second step is determine the domain of n1 equal r difference the set of zeros of denominator, which are negative 4 and negative 1. This is about n1 of x. The same steps will be taken for n2 of x. n2 of x equals after removing the common factor with n1 of x equals x minus 3 or x plus 1. 1. N2 of x equals, we factorize both numerator and denominator. X times x, negative 3 equal negative times positive 3, 1. The numerator is perfect square, which is x plus 1 over 2. The domain here, the domain d2 equal r difference, the set of zeros of the denominator, which is negative 1. Removing the common factors, then n2 of x equals x minus 3 over x plus 1. Number 2. From 1 and 2, we find that n1 and n2 has the same rule after reducing them. After reducing them, they have the same rule. But they have different domain. The domain here is r difference negative 4 and negative 1. The domain here is r difference negative 1. So n1 not equal n2, except in the common denominator. Then, in the common domain, which is d equal d1 union d2 equal r difference negative 1 and negative 1 and negative 4. This is the common domain. In this domain, n1 of x equals n2 of x in the common domain. This is the end of our lesson. It is stay to put the homework. The homework is from student book. Homework from student book. Page 27, exercises 2, 3, number 2, A plus C, number 3, B plus G, number 4, B plus D, B plus C. This is the end of our lesson today, and I hope you success.